Well, I guess we'll get started here. So hello, everyone, and welcome to the sixth webinar in a series of 8 for the Forestry Adaptation Community of Practice. For those of you who don't know me, my name is Annette Morand, and I am the facilitator of the online adaptation communities of practice. And those are run by us here at OKR, which is the Ontario Centre for Climate Impacts and Adaptation Resources. And we're located at Laurentian University in Sudbury, Ontario. So the way the webinar will run is as follows. So after this very short introduction, we'll have the main presentation, which will go for about 35 to 45 minutes. And then at the end of the webinar, we'll have some time left over for any questions that you might have for the presenter. So if you have any questions during the webinar, we just ask that you do please hold them until the end. And before we get going, I just have a few housekeeping items to go over. So first, for those of you who dialed into the conference call line, your lines have been automatically muted, and the reason for this is just to avoid any audio distractions or feedback during the webinar. So to ask a question during the Q&A session, all you'll have to do is dial *6, and that will unmute your lines. But please do keep them muted during the presentation. Also, you'll notice that there is a chat box on the left-hand side of your screen. So you can use this chat box to field any questions that you might have for the presenter during the question and answer period. As well, if you have any technical difficulties during the webinar, you can use this chat area to type your message, or you can also click on my name and send me a private message, and I can try to help you as best as I can. I also want to mention that we are recording the webinar today, and I'll be sending out a copy of the recording to all those who have pre-registered with me, and we'll also be posting it to the Community of Practice website. And finally, I know we have some people on the line today who may not be familiar with what the Forestry Adaptation Community of Practice, or the FACoP, is. So I wanted to take this opportunity to just quickly mention that it's an interactive online community, and it's dedicated to those who are either working in forestry or who are just interested in forestry and climate change adaptation in Canada. It includes features such as news articles, events, an online library with tons of resources, discussion forums, and much, much more. So it's free to join. So if there's anybody on the line today who's interested in learning more about the FACoP, please just click on the link in the chat box for more information and to register. So with that being said, we are very excited to have Paul Nikiema on the line with us today to talk about assessing climate change impacts, vulnerability, and adaptation, a case study of the Pineland forest section in Southeastern Manitoba. And just so you know a little bit more about your presenter, Paul has been a climate change specialist with the Forestry and Peatlands Management Branch of Manitoba Conservation and Water Stewardship since April 2013. He received a PhD in forestry from Michigan State University, a master's degree in renewable natural resources management with a major in agroforestry from the Kwame Nkrumah University of Science and Technology in Ghana, and a bachelor's degree in forestry from the University of Ouagadougou in Burkina Faso. So prior to joining Manitoba Conservation, Paul worked in the Department of Soil Science at the University of Manitoba for 2 years as a postdoctoral research fellow. And from 1991 to 2006, he also worked as a research scientist in agroforestry at l'Institut de l'Environnement et des Recherches Agricoles in Burkina Faso. So on behalf of everyone joining us, I'd like to extend a very, very warm welcome to you, Paul, for taking the time to present this webinar for us today. It's very much appreciated. So without further ado, I will now turn things over to you.
Yeah, thank you very much for your kind introduction, Annette. And good afternoon, everyone, for joining. Thank you for joining. What I will be presenting today, what I will be describing today is a case study, the vulnerability assessment study that we conducted in one of our forest sections, the Pineland forest section in Southeastern Manitoba. And this study was part of a 20 years of forest management planning process, a forest management plan that we were developing for the same forest section. And we have seen this as an opportunity to do this study so that we make sure to incorporate climate change consideration into the new forest management. The presentation overview is going to be as follows. I'm going to talk, start with the study objective, then present the study area, talk about the method that we use, and then present some key results and proceed with a take-home message. The objective of these assessments were twofold. First, to investigate the extent to which forest and forest management in the study area are vulnerable to climate change, but also to identify and propose a potential adaptation option and strategy that can minimize the negative effect of climate change. The study area, the Pineland forest area, is located in the southeastern corner of Manitoba. It is the area that is shown in red here, and it covers about 1.2 billion acres of land. It covers majorly two ecozones, the boreal shield that covers about 90% of the area, and the boreal plain represents only 10% of the area. And as we can see, the area is almost at the intersection between the two biomes, the prairie grassland that is in the west and south of the assessment area, and the boreal forest in the north. So the area is located in a transitional zone between these two ecosystems, and making it very vulnerable to climate change. We are particularly concerned that with further warming, the prairie grassland will expand into these current suitable forest habitats. It's quite a fragmented forested area, as we can see in these land cover type maps. About 70% of the area is forested, from productive forest to potentially productive forest and non-productive forest. Non-forested area represents 21% of the land base, and is majorly composed of agricultural land and urban area. So it's quite a fragmented forest area, and making it to be vulnerable to climate change. In the forest, we can find 4 types of forest habitat, depending on the topography, soil type, drainage, and moisture conditions. In the upland area, the first 2 habitats are in the upland area, habitat with very dry, shallow, poor nutrients, sandy soils with very low water holding capacity. And in the very dry sites, we do have generally chat pine has forest type. And in the dry sites, in addition to chat pine, we do have red pine, half pine, and black spruce. And these upland and sandy land areas are experiencing frequent drought and forest fire issues. And then in the lowland area, we have habitat 3 and 4, habitat with favorable moisture conditions to excessive moisture in the lowland area. And we do find stand like pure stand of black spruce and tamarack. Some of these, the third habitat, the favorable moisture habitat is quite well drained with deep organic soil, while some areas of habitat 4 is not well drained, it's poorly drained, and so we do have frequent seasonal flooding issue that may lead to poor root aeration, and that limits tree and forest growth in this area. The area also experienced in recent years frequent severe windstorm causing tree blowdown. We recorded 3 major severe windstorm that caused blowdown in the area in 2005, 2007, and most recently in 2012. The 2012 blowdown was quite severe and affected approximately 800 hectares of mature just pine forest. And we estimated that about 110,000 cubic meters of just pine timber were damaged through these blowdowns. And if we compare this to the annual allowable cuts for softwoods and for this forest section, that is about estimated to be about 125,000 cubic meters, it is quite consistent, these timber loss. I'm going to talk about the method that we use. We use 3 complementary approaches. The first approach is the CTF adaptation framework, the Guidebook approach that was recently published by Edward et al. 2014. And we also use a tool called ADAPTool, Adaptive Design and Assessment Policy Tool, designed and developed by the International Institute for Self-Development. And we also use some modeling and simulation analysis to conduct the study. This chart here shows the CTF Guidebook approach. It has 4 stages and 6 different steps. The first stage starts with exploring the organization that is conducting the vulnerability assessment Readiness. And we explore our readiness to conduct this study by looking at the following aspects. We looked at our staff level of awareness, understanding, and perception about climate change and climate change impact in forests. And we look at also the various staff that we have and the expertise that they have to if we have the expertise that we need to conduct this study. And we also looked at our institution that we can collaborate with to conduct this study, where collaborating with scientists from the Saskatchewan Research Council, the Canadian Forest Service in Edmonton, and scientists from ISD. And we also looked at the availability of funds that we can put into organizing meetings and workshops to conduct the study. And stage 2 involve collecting secondary data, historical climate data, and also describing, collecting data to describe the forest condition, and also future climate scenario development. And we were able to obtain historical climate data from 2 weather stations, Environment Canada weather stations located in the assessment area. Those sites, weather stations were located in Sprague here and in Pinawa here. So we were able to obtain climate data dating back from 1916 to 2010 that we use to look at climate trend in the assessment area. Regarding the forest information concerning the forest condition, we rely most on literature review. We recently completed a wood supply analysis for the forest section that provided us with quite significant, some good data. It was a good data source for us to use, and we did also get some information from other studies that were conducted in the assessment area. And for future climate scenario data development, we rely from data that were provided to us from TFS. David Price and his modeling team provided us with 10 by 10 downscale climate data. He used the most recent IPCC scenario developed by IPCC, and that were used in the most recent the assessment reports, the fifth assessment reports called RPCs, representative concentration pathway. So, and they use 4 different global climate models to do the modeling. For stage 3 and 4, we form an assessment team composed of staff within our branch, and the team was assisted by scientists from the Canadian Forest TFS and also the Saskatchewan Research Council, Mark Johnson, and we organized a series of meetings and workshops. For instance, we organized 2 workshops in Winnipeg. One was in the summer of 2013, and the second workshop was in last year, March of 2014. So, and during the workshop, the team was led through an informal and structured discussion process following the pre-prepared table in the guidebook to look at climate change impact on the forest condition or in our ability to achieve forest management in the assessment area, and then examine adaptation options that can contribute to reduce the impact. The second approach that we use is the ADAPTool, as I said. It's a simple tool developed by ISD, a Microsoft-based workbook, and it can be used to evaluate public policy programs for their ability to contribute to the capacity of key economic sectors like mining, agriculture, and forestry to adapt to socio-economic or ecological stresses like climate change or market pricing, price volatility. And the assessment is done through answering a series of questions covering both for planned adaptation needs, but also looking at how the policy or program themselves are affected by climate change. And using this tool, we evaluated three of our program policy. We evaluated, analyzed our timber quarter allocation policy. Also, we analyzed our forest renewal program and wood supply process. The modeling work was done by Dr. Mark Johnson from the Saskatchewan Research Council. He used two modeling tools, Landis, which is a process-based model, and Pineland, a biogeochemistry model to explore climate change impact on forest, tree species and forest biomass, but also the impact on fire statistics. The model outputs were, as I said, biomass over time. He ran the model over 300 years horizon, and then he looked at also fire statistics like area burn, number of fires, fire severity, and he also produced modified yield curve for us, and look at climate moisture index by producing different maps by 2020, 2050, 2080 map, CMI map for us. We're going to show some of the results that we got. This is the observed temperature and precipitation trend from the data that we collected from the two weather stations at Sprague and Pinawa. The graph in the right, in the left panel is the mean yearly temperature from 1920 to 2010, and this is 10 years averages, and also in the right side here, this is the yearly precipitation data, and as we can see, both temperature and precipitation increase in the assessment area, and we estimate that the temperature in the Pineland area currently is about 1.6 degrees Celsius warmer than it was in the early 1900s, and the precipitation increased by about 120 millimeters. This is shooter temperature projection using the climate change scenario, the RPCs, representative concentration pathway. The red lines and shaded area is the RPC 8.5, and the green one, RPC, let's say RPC 8.5 is the high-end greenhouse gas emission scenario. The scenario assuming a business as usual scenario. Then RPC 2.6 is a low emission scenario. And the RPC 4.5 is a medium range scenario. The line that we see represents 10 years moving averages, and the shaded areas are flat or less standard deviation, standard error. And we, as we can see, by 2100, temperature is going to increase by about in the range of 3.5 to 9 degrees Celsius. This is about twice as much as what IPCC reported globally. This is the precipitation projection that we made using the observed data, climate data, precipitation data, and also the simulated precipitation data using the three scenarios. And we do see a trend of increase that is there, but precipitation prediction is associated with much higher uncertainty, as shown by the wider standard error in this. And we estimate that by 2100, the area may still be receiving about 50 to 100, depending on the scenario, 100 millimeters of rain, than more rain than it's received now. This is a scatter plot and regression lines, temperature increase versus precipitation change for the annual precipitation data that we collected, that we have, and we break this also into season, looking at it seasonally. Winter, spring, fall, and summer. And as we can, I have an issue with my mouse. For the annual, we do see a strong positive correlation between temperature increase and precipitation for the annual data, but also for the spring, winter, and summer, and fall. But summer, we do see an opposite, a negative correlation between temperature increase and precipitation. So, meaning that summer will receive less precipitation, may receive less precipitation, and this may increase the likelihood of droughts during the summer, which is the growing season. Using the guidebook, we analyze the impact of climate change on the forest condition. The assessment team identified forest condition and processes that can be impacted by climate change. Things like species composition, growth and productivity, natural regeneration success, and so on and so forth. And then the team evaluated the impact, the current impact, the impact by 2020, 2050, and towards the end of the century. The green color means low impact, yellow moderate impact, and when the impact is high, a red color is given. So, and as we can see, let's say this assessment was based on the business as usual climate change scenario, the high-end climate change scenario. And as we can see, currently, most of the forest conditions and processes that we identified received low impact, but as we move towards the end of the century, the impacts shift from low to medium and become high by the end of the century. And in this table, the forest management planning team produced a draft of forest management objectives that the assessment team used to see how each forest management objective that was defined by the forest management planning team, how this objective will be vulnerable to climate change currently by 2020, 2050, and towards the end of the century. And as we can see, for most of them currently and in the short term, most of the forest management objectives can be achieved. They are less vulnerable, but as we move towards the end of the century, most of them it will become very challenging to deliver them, to achieve them. This shows, this is a summary analysis, the results of the policy analysis using the ADAPTool. And we do have sorry, the pointer is not working properly, but when the policy falls in the green area that is on top, it means that it supports well planned adaptation needs as well as autonomous adaptation needs. In the red area suggests that the red area here means that there is some issue in either planned adaptation need or autonomous adaptation need. And in the yellow area here, it suggests that the policy or program is marginally supports quite well, marginally well adaptation, autonomous and planned adaptation needs. And as we can see, all three, based on the position of the three policy, we can say that they did their score fairly well, and these suggest that they support quite well both planned and autonomous adaptability, and they are very flexible in light of uncertainty. The model results, Pineland and Landis results produced by Dr. Mark. This is, for instance, average biomass for each ecoregion using the RCP 2.6 on the left panel, and RCP 8.5 in the right panel. And the projection, the biomass projection was done over 300 years horizon, and he used the habitat type, or he called them ecoregions. That's the four ecoregions. What we have here is the biomass level for each ecoregion over 300 years period. And as we can see, for some ecoregions, for instance, in ecoregions, in ecoregions 4 and 3, where these are ecoregions with plentiful of moisture and rich organic soil. The biomass level for these two ecoregions for the RPC, the the business as usual scenario, is generally lower than the biomass for the less warmer climate scenario. He also produced fire statistics, as I said, and this is an example of the number of fire by ecoregions. It distinguished two ecoregions, ecoregion 1 and 2, and we see that for this panel is for RPC 8.5, and this graph is number of fires for RPC 2.6. And as we can see here, in these two ecoregions, the tendency, we have a tendency, a decline number of fire over time. But this tendency is less clear in the low emission scenario. And this may be explained by the fact that it is also observed that in this ecoregion, hardwood were increasingly becoming more dominant over time, and as the landscape shifts from softwood dominance to hardwood dominance, so less more flammable species to less flammable species. The fire hazards, like number of fire intensity, also reduces. From what we can say from the model results, summary is that he produced climate moisture index map that shows a strong drying trend across the study area, and with all the areas becoming climatically unsuitable for to support forest cover by the end of the century. And we also found that most coniferous species are projected to decline in biomass and in dominance as the area becomes less suitable for them. On the other hand, hardwood species increase in dominance. And these shifts in species composition is affecting fire occurrence that is projected to decrease towards the end of the century. And the next step was to come up with forest management adaptation options to help reduce the impact, climate impact on the forest. And we identified a number of adaptation options. I'm not going to talk about all of them, but a few of them. We propose to include assisted migration have a way to help a species that may the area may become the area may become less suitable for some species, but suitable for others. Assisted migration could be an option to help species that is or tree provenances that is some kilometers away from the currently some few kilometers away from the assessment area to come into the area, and we also suggested that we need to enhance tree species regeneration, and this can be done through different means by introducing most drought-resistant species or provenances, or conducting site improvements like through scarification to help tree naturally regenerate, or do some fertilization, or even probably irrigation to help enhance the regeneration success. Also, we saw that forest fragmentation is currently an issue, and we need to prevent the forest from further fragmentation, and this can be done through preventing preventing forest area to be converted into agricultural land, or establishing migration corridors to facilitate plant, tree, and wildlife species migration. Also, we may need to reduce the impact of forest disturbances like blowdown and fire. The blowdown affects majorly mature jack pine species, trees, and to prevent that, we can use options we can use shorter rotation as a way to prevent to reduce the impact of forest disturbances. And we also need to incorporate climate change impact into our yield curve development. Until now, our yield curves are developed without integrating climate change effect, and these can lead to wrong forecasting of forest productivity and timber removal rate. So to improve that, we need to incorporate climate change impact into the yield curve development. And we saw that with further warming, winter may become shorter, and we know that most of the harvesting operation is occurring during the winter, and these may, and as the climate gets warmer, the time for the period for harvest may be reduced, and we need to maybe come up with some new harvesting techniques that to make sure that forest harvest activities are still going on. To conclude, we use three complementary approaches in this study, and we saw that climate change is going to pose quite significant risk to the assessment area. Temperature is going to increase twice, 2 times faster than the global average. And but we also saw that there may be some opportunity. Precipitation may increase, and the growing season also may increase, which may lead to increased tree growth and productivity. So we it could be a win-win situation. It could be some challenges, but there are some opportunities. And we found that the upland forest, the dry, currently dry forest habitat, and coniferous species are the most vulnerable and require specific support. And we propose some adaptation options with and we believe that implementing these adaptation options can reduce the impact of climate change. And the study, many people have contributed to this study, the successful completion of this study. We have Jason Edward, who developed the guidebook and who were ready to come here to help us understand the guidebook and go through the process of using the guidebook to conduct the vulnerability assessment. We obtained also projected climate data from David Price, and the modeling work was done by Dr. Mark Jason from the Saskatchewan Research Council, and we ISD through Dimple and Daniela conducted used the ADAPTool to evaluate our program adaptability to contribution to climate change needs. And the forestry staff we formed a very nice team that worked hard to complete these vulnerability assessments, and also other colleagues from other branch within Manitoba Conservation also contributed. I mentioned Randall, Simcoe, and Raymond from the climate change branch who contributed to this study. With these, I'm pretty much done. And thank you for your attention. And if you have any questions, you can answer.
Perfect. Okay, thanks so much, Paul. So we now have a few minutes left for questions. So if anybody has any questions or comments, now is your time to ask. Again, If you'd like to use the chat box, please feel free to go ahead and type out your question and I can read it out loud for everybody. And if you're on the conference call line with us and would prefer to ask a question over the telephone, just hit *6 and that will unmute your line. So before we get into questions, Cindy Pierce did have a request, Paul, if we could send them the link to the full report. So I'm wondering if you can send that to me and then I can send that out to everybody later this afternoon.
The report is still in the draft format. The report was presented to our managers and our director about 3 weeks ago, and we are planning to make a summary report to present it to our minister, and from there we finalize it before making it available. As we do have the intermediary report, MAC report, but we haven't posted it also online, and ISD report also is here, but we haven't posted them online yet.
Okay, that's no problem. We'll look forward to when they get posted. So we have another question here as well. So were any adaptations identified to harvest, use, distributed timber, particularly blowdowns?
Well, what we propose is to after a blowdown occurs, we need to make sure that we salvage the area very quickly to prevent the dry material to. This can be a source of forest fire occurrence. So we make sure that we salvage the area and remove the dead materials very quickly.
Perfect. Okay, thank you very much. Is there anybody on the conference call line that would like to ask a question? If so, just hit *6. Give everybody a few seconds here. I see some other people typing, so we'll just wait a little bit. While we're waiting, Paul, I just have a quick question. So the case study that you presented today was from one forest section in Manitoba. So I'm just wondering if you have any plans to conduct similar assessments in other forest areas of the province.
Yeah, that's a good question. Yeah, we from conducting this study, for sure, we one of the intents was to build some capacity to get used with the approach of conducting vulnerability assessments, and then we'll either take it to different forest area or engage our forest industry to start incorporating climate change consideration into their operation. So we may take it to we haven't decided yet, but we may take it to a different area, but we'll more and more encourage the forest industry to do vulnerability assessment as part of their activity.
Okay, thank you. Perfect. So Miriam has a follow-up question to the previous question. So how would the salvaged wood be processed? Paul, are you still with us?
Yeah, we do have a biomass plant in the Pineland nursery, and we could use this biomass as bioenergy in this facility.
Okay, thank you very much. Any other questions on the conference call line? So we'll give one last chance for any questions on the conference call line, and then we'll wrap things up. Okay, well, if there are no more questions, I guess we'll wrap up here. So again, thank you everybody for joining us today for the FACoP webinar. We hope you enjoyed it. Obviously, a very, very big thank you goes out to you, Paul, for your time and effort and for a great presentation. So any last comments from you before we sign off here?
For me, no, I don't have any comments.
Okay, perfect. Okay, well, that's everything then. So thanks again, everybody, and have a great week. Thanks for